All right, this is geometry lesson 8.3, solving right triangles. We found sides in 8.2 and learned how to set up the SOHCAHTOA stuff. So today we're going to go through how to kind of find angles. All right, use a trig ratio cosine A equals 24 over 25 to determine which triangle is angle A. Well, if we look at angle 1, cosine would be adjacent, which would be 1.4 over 5. If we look at angle 2, cosine would be 4.8 over 5. So which one of those ratios is the same as 24 over 25? Well, that's really close to 1, so you could see that this would be 4.8, which would mean angle A would correspond with angle 2. All right, so set it up, see which one is the same. Use the given ratio to determine which one is A again. So this time we're dealing with sine, so angle 1 would be there. Sine would be opposite over hypotenuse. If we used angle 2, sine would be opposite over hypotenuse. 14.4 over 30.6. So you can see that 8 over 17 is pretty the same as that, which would mean angle 2 would be our answer to that problem. So set it up and see which one matches the ratio as you go. All right. In lesson 8.2, we learned the sine of 30 was 0.5. Conversely, if you know that the sine of acute angle is 0.5, you know that the angle is going to be 30. This is written as the inverse sine of 0.5 equals 30. So once again, if you know the sine, cosine, or tangent of an acute angle measure, then the inverse sine, inverse cosine, and inverse tangent can be used to solve for the angle. So remember again, make sure you are in degree mode anytime you are dealing with trig. But you can use the inverse sine. So if you hit second and then sine, or second cosine, second tangent, that would be the inverse button on your calculator. Okay, so let's try that. So on our calc, take the second cosine of 0.87, 29.54. But that would be in degrees, so we want to round our degrees to the nearest whole degree. So we would say that's 30 degrees. Inverse sine of 0.85 is 58.2, but we're going to round to the nearest whole degree, so 58 degrees. And the inverse tangent of 0.71 is 35 degrees. All right, so to find an angle, you're going to use the inverse whatever trig ratio and round to the nearest whole degree. All right, using given measures to find unknown angles and side lengths is known as solving a triangle. To solve a right triangle, you got to find all the missing pieces parts using trig or Pythagorean theorem as you go. All right, find the unknown measures, round lengths to the nearest hundredth and angles to the nearest degree. All right, so we're missing R, T, and ST. Let's find R first. Doesn't matter which one you pick first, but we're going to use trig to find that angle. Okay, so R is there, so 5 would be adjacent, and 5.7 would be hypotenuse. So that would be cosine R equals 5 over 5.7. Okay, so we're finding an angle. To find an angle, it's just one step. You're just going to take the inverse cosine of the fraction. So on your calculator, take the inverse cosine of 5 over 5.7 and hit enter. And you can see that's 28.69. So we would round that up to 29 degrees. So R is 29 degrees using trig to find the angle. Now T is easy. We just take 90 minus 29, which is 61 degrees. Okay, now we can set up using trig to find X. Doesn't matter which one you use. Let's use 29. So X is opposite. 5 would be adjacent. So we could say tangent of 29 equals X over 5. Now we're finding a side. So we take X on the top. So 5 times the tangent of 29 gives us 2.77. Okay, so solving a triangle. Sides to the nearest hundredth, angles to the nearest degree. Let's try that again. If they give you the degree, if they give you two of the angles, it's easy to find D. We just take 90 minus 58, which is 32. Okay, now we are going to need to find X and we are going to need to find Y because we don't know those sides. All right, so let's use 58. 14 is opposite. Y is hypotenuse. Opposite and hypotenuse is sine. So we can say the sine of 58 equals 14 over Y. Cross multiply, which means I'm going to take 14, since Y is on the bottom, divided by the sine of 58, 16.51. So the hypotenuse is approximately 16.51. All right. To find X, I could use opposite and adjacent there. So if we're still using 58, so tan 58 equals 14 over X. So we take 14 divided by the tangent of 58, 8.75. Okay? If you use 32 in your angle, you'd still get the same answers. You'd set them up a little bit differently, but still should work out just fine for you. All right, so solving a triangle is finding all the unknown pieces parts. A highway sign warns that a section of road ahead has a 7% grade. To the nearest degree, what angle does the road make with the horizontal? All right, so there's our right angle. We're trying to find that angle right there. All right, 7% grade is like slope. Slope is rise over run. So if we write that as a fraction, that's 7 over 100. Well, that's rise over run. So 7 over 100, rise over run. So we can see that that's opposite and adjacent. So tan of theta equals 7 over 100. So on your calculator, you're just going to take the inverse tangent of 7 over 100. It gives you about 4 degrees. Anytime you're dealing with grade or slope problems, it's always going to be tangent because you are dealing with rise over run. Baldwin Street in New Zealand is the steepest street in the world. It has a grade of 38%. To the nearest degree, what angle does it make with the horizontal? Well, trying to find this angle right here, rise over run. So we're going to take the tangent, inverse tangent of 38 over 100. So inverse tan, 0.38, 20.8. So we'd round that up to the nearest degree, 21 degrees. Steepest street in the world. Rise over run, always going to be with tan, anytime you're dealing with slope or grade. All right, that's a wrap for 8-3.